Hello, everyone! Welcome to our life! Are you sad? Are you hurt? Are you lost? Are you lonely? Worry no more. You are at the right channel. Welcome to Exclusive!
In this video, we will be focusing with well-defined set and subsets. An important concept in all branches of mathematics is set. A set is a well-defined group of objects called elements that share a common characteristic. These objects in a set are called elements or members of the set. The objects in a set can be anything: numbers, letters, symbols, names, things, and etc. Sets are named using uppercase letters denoted by A, B, C, and up to Z. The notation A element A is used to denote that A is an element of a set A. This symbol is used to denote element. The groups are called sets for as long as the objects in the group share a common characteristic and are thus well defined. For example, you may identify 3 of the objects that belong to the set of head covering or simply hats. Say for example, ladies' hats, baseball cap, and helicopter clown hat. If you were to list the elements of the set of hats, the set could be denoted as this. Set of hats equals ladies' hats, baseball cap, helicopter clown hat. Sets are usually named using capital letters. So let's name this set as A. Then we have set A equals ladies' hats, baseball cap, helicopter clown hat. At the same time, we use a special character E to say that something is an element of a set. For example, baseball cap is an element of A. Again, this is read as baseball cap is an element of A. How do we know that a collection or group of objects is a well-defined set? Consider the given 2 sets. Set A, subjects that grade 7 students will study this school year. Is it well-defined or not? Yes, set A containing the subjects that grade 7 students will study this school year is considered a well-defined set. Why? Because all grade 7 students will study the set of subjects. Set B. Difficult subjects that grade 7 students will study this school year. Is it well-defined or not? No. Set B containing the difficult subjects that grade 7 students will study this year is not a well-defined set. It is simply because some of the students may have difficulty in mathematics while other students may find mathematics easy. Thus, we could not determine whether or not mathematics is an element in set B. Here are more examples. Determine whether the given set is well-defined or not. Set A. Good actress in the Philippines. Is it well-defined or not? No. Set A is not a well-defined set because the elements of the set will vary basing on the perspective of every person. Say for example, Kim Chiu. Some would say that Kim Chiu is a good actress, while others may not. Set B. Region in the Philippines. Is it a well-defined set or not? Yes. Set B is considered a well-defined set because it is very clear that there are no other elements in set B but region 1 to 13, ARMM, CAR, and NCR. Set C, even prime number. Is it a well-defined set or not? Yes. Set C is a well-defined set because it has only one even prime number, which is 2. Moreover, there are two ways of writing sets: the Rooster Form and the Set Builder Form. In Rooster Form, the set can be defined by listing all its elements, separated by commas and enclosed within braces. While in Set Builder Form, the set can be defined by stating the property describing the elements. Consider the given sets below and express the given sets using Rooster Form. A. Set A consists of the vowels of the English alphabet. So we have set A equals the set A, E, I, O, and U, because A, E, I, O, and U are the only vowels in the English alphabet. B. Grade 7 subjects that students will take this school year. We have B equals the set English, Science, Mathematics, Filipino, Araling Panlipunan, ESP, MAPE, and TLE. Why? Because these are all the subjects that grade 7 students will take this school year. C. Set C consists of counting numbers. So we have set C equals the set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. In addition, if you want to express it in set builder form, we can show it this way. A. Set A consists of the vowels of the English alphabet. So we have that expression. And this symbol is used to represent such that. So the whole expression is read as set A equals the set of X such that X is a vowel of English alphabet. Set B consists of grade 7 subjects that students will take this school year. We have set B equals the set X such that X is a grade 7 subjects students to take this school year. Set C consists of counting numbers. So we have also set C equals set X such that X is a counting number. A set can be classified into finite set and infinite set. A finite set is a set which contains a definite number of elements, or the elements can be counted. For example, the set of all colors in the rainbow. Set R is a finite set because the elements are definite or can be counted. Set of vowels of the English alphabet. Set A has only 5 elements, thus it is a finite set. An infinite set is a set whose elements are too many to be listed, such as sets containing never-ending elements. Example: set of all prime numbers. It is an infinite set because there are infinitely many prime numbers. Set of counting numbers. Set C is an example of infinite set because counting the elements of set C cannot come to an end. That is why we put ellipses at the end of the identified element to show that there are still more elements in the set. A set is a subset of another set if all elements of the first set are also elements of the second set. This symbol is used to denote subset. This symbol stands for is a subset of or is contained in. For example, let A be equal to the set 2, 4, 6 and set B be equal to the set 6, 4, 8, 2. Here, A is a subset of B, since all the elements of set A, 2, 4, 6 are contained in set B. But B is not a subset of A, since all the elements of set B are not contained in set E. That is, element 8 is not found in A. To identify the number of subsets in a set, use the formula 2 raised to the power n, where n is the number of elements of the given set. For example, set C equals the set 1, 2, and 3. To find the number of subsets, first use the formula 2 raised to the power n. And since there are 3 elements in the set, substitute 3 to n. Then it will become 2 raised to the power 3. Simplifying, 2 raised to the power 3 will become 8. And thus, set C has 8 subsets. A set is considered a proper subset of another set if and only if every element of the first set is also an element of another set, and that another set contains at least one element that is not in the first set. This symbol is used to denote proper subset. This symbol denoting proper subset is read as is a proper subset of. For example, let A be equal to the set 2, 4, 6 and B be equal to 6, 4, 8, 2. Here, we could say that A is a proper subset of B because all the elements in set A is found in set B, and there is an element in set B that is not found in A, which is the element 8. To identify the number of proper subsets in a given set, use the formula 2 raised to the power n minus 1, where n is the number of elements of the given set. For example, set A is equal to 2, 4, and 6. And to identify the number of subsets in set A, first, we use the formula 2n minus 1. And counting the number of elements in set A, we have 3. Thus, substituting 3 to n, we have 2 raised to the power 3 minus 1. Simplifying, 2 to the 3 is equal to 8. Thus, we have 8 minus 1. Simplifying further, 8 minus 1 is equal to 7. Thus, set A has 7 proper subsets. Take note, no set is a proper subset of itself.
If you find the lesson confusing, feel free to hit the replay button. Replay! 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 Replay!